There you go. Pass my business cards around so that if anybody ever wants to send me an email, pass them around. And there's one person out. When he comes back, give him one.
Oh, sorry.
Yes, yeah.
And you can hold this. You can hold that. Thank you.
It's so awkward.
What's awkward?
He literally just went like this because he wanted food.
Mr. Wakefield, you didn't have your breakfast, didn't you?
I did have breakfast. I just had breakfast like 7 hours ago. So.
That's not breakfast, man. That was a late dinner.
What?
This is 7 hours ago.
Come on in.
Is this a seminar?
Yeah, come on in. There is the business card that you can grab at the end.
Okay.
Do we need more business cards, Rob? No, hand me, I have, there, here. Pass them out. Okay. Okay. Rob, hand these out. Please. Take them out and hand them out. Make sure everybody gets one. Did this gentleman get one? How about the gentleman over there?
I got one.
Okay.
I think so. If I don't go out of town.
Well, thanks for coming today. And today's presentation is kind of unique. This is related to electromagnetic excitation. And according to Dr. Bess, we have a sufficient energy that we can collect from our environment. And this is somewhat related to the course that we are taking right now. And before he can start presentation, let me give you as brief introduction as possible. And then he can have more time for presentation. He graduated from Johns Hopkins with a PhD in mathematics in 1955. And he was a Rhodes Scholar a few years earlier. And one more important thing is that he had a personal meeting with Dr. Einstein for 15 minutes.
Yeah, well, there was one other man, but the other man sat silent. So I can say I was alone with Einstein for 15 minutes.
And for that, here's Dr. Bass. And before we can even present, let me just give you this video clip so that you can see what the Schumann resonance is all about.
Should we turn on the lights?
I don't think it's going to help that much. As you can see, there is a lightning anywhere around the globe. There will be 44 lightning each second. And once you have a lightning, the wave is going to be propagating around the Earth and becomes resonance. And according to his calculation, the energy is just enormous, okay? Much more than what you consume every year, okay? So that's it for that, Dr. Bass. Let's see.
So you're
Okay, you can just
yeah,
click this one,
at a
yes.
time. All right, yes. Before I actually begin, I want to tell a little joke that's very relevant, and you can edit it out if you don't like the joke. How many people here have heard of cold fusion? One guy. Okay, meaning cold nuclear fusion. It came out 24 years ago and very controversial. Well, about 15, 20 years ago, the most distinguished alumnus of Ohio State University bypassed the chairman of the physics department. He went to the president of the university. He says, I want you to invite Dr. Bass to talk to us about cold fusion. And so when I came there was a nice luncheon, and the man who'd got me invited, he was there, and the whole faculty was there, and they said, the reason we invited you to this luncheon is we want to tell you face to face why we are none of us coming to your lecture and why we have ordered all of our students not to come to your lecture, because if we let our students hear you talk about cold fusion, they would become unemployable. Okay, now I call that the OSU syndrome because that was Ohio State University. The chairman of the physics department was afraid his students would become unemployable if they listened to me. What I'm going to say today is even more controversial, so I have to warn you. You be careful whom you let know that you have thought about this, or you might become unemployable. Okay. Now, let's see. Now, okay. Any who didn't get my business card, ask my son over in the corner. He has a lot of business cards you can pass out. So I would like to hear by email from anyone who's interested, because I can send you copies of technical papers. For instance, here's one, Satellite Observation of Schumann Resonances in the Earth's Ionosphere. Here's another one, Review and Evaluation of Lightning Return Stroke Models, including some aspects of their application. And these are all well funded by National Aeronautics and Space Administration, NASA. And then, of course, this is a very classical book. Probably Professor Lee has told you about it, Classical Electrodynamics by John David Jackson, who's at Lawrence Berkeley Laboratory. And he does have several pages on the Schumann resonances in this book, and I'll show you a formula from this book later on. But I would like to tell you another joke. I contacted him, and he knew my email address, and I said, I would like to get you involved in this business. And he wrote me back, and he says, life is too short for quixotic adventures. So my email address is Don Quixote, RWB from my initials. So he thought one of my bosses accused me of having a Don Quixote complex, so that's why I used it for my email address. Don Quixote, okay. Now, here are some of the books that I would advise you, if you get very interested in this. The most valuable book is John E. Morey. He's the son of T. Henry Morey, and it's called The Sea of Energy in Which the Earth Floats. Now, Morey himself discovered limitlessly renewable free energy, but he may have misunderstood where it came from. But anyway, this book, you can buy it from a company called XLIBRIS, Ex Libris, and the book has a new introduction. It was reprinted in a 1930 book, and it has a new foreword by me on page whatever. Anyway, there's a foreword by me, and it also has a new conclusion by me. So I think that adds a little credibility to my talking on the subject, because I know the son of Morey. He was a teenager when Morey made his big discoveries, but he always watched his father. If he was a good boy, the mother would let him watch his father at work. If he was a bad boy, they would punish him by saying, you can't watch your father. So anyway, this is The Sea of Energy in Which the Earth Floats. Now here's a lot of books about it. This one has The Scientist, the Madman, the Thief, and Their Light Bulb. And one person says it's the biggest scandal in the history of science, the biggest scandal in the history of science. Then here's another book that has a whole lot of papers on Morey and other things. Tesla, and also, and I'll mention why Tesla is in the picture. Oh, here's what I call them. I don't call them the Schumann resonances. I call them the Fitzgerald-Tesla-Schumann resonances. Now, in the book, he says, well, it's amazing that the great genius Tesla discovered these things 50 years before Schumann. Tesla discovered them experimentally. He revealed them in a patent application that he applied for in 1895, but the patent wasn't issued until 1905. So Tesla is a second discoverer, but if you go to this man's website, it's not in the book, but in his website where he has errata for the book, misspellings and stuff, he says, somebody brought to my attention that this was published in England in 1893 by Fitzgerald, who published it in Science. So I call them the Fitzgerald-Tesla-Schumann resonances. Now, here's a couple of popular books that have chapters about Morey. Breakthrough Power by Gene Manning and Joel Garbon, and The Coming Energy Revolution by Gene Manning. They have chapters on it. But she has the best chapter of all about this stuff in this big, thick book here. She copied a lot out of Morey's own book. This is a book on suppressed inventions. And she has a whole chapter called Gunfire in the Laboratory. And if you read it, it's like a thriller because people really tried to murder him. They would phone up and tell his wife, you tell your husband to quit or we'll kill you, and she's driving down the road and a bullet whistles by, and they deliberately missed her, so he got bulletproof glass on his car. So they tried to frighten him into quitting, and so on and so on. Now, here's another book that is, anyone who gets real interested needs to get this book, although I have great respect for the author. He passed all the requirements for a PhD except a thesis, but I would happily nominate him for an honorary PhD because of all the work he's done on the subject. However, with respect, I don't agree with him of where Morey was getting the free energy, and here's the difference between him and me. If you study quantum mechanics, you find out why a crystal, even at zero, you cool it down until arbitrarily close to zero, everything trembles a little bit. And everything trembles a little bit, and they call that zero-point energy. Now, you've probably heard of the famous Nobel Prize winner Feynman, F-E-Y-N-M-A-N, Feynman. And Feynman famously said, if you take your cupped hands and you look at the volume in your cupped hands, and you got a vacuum anywhere in the whole universe, the volume of your cupped hands, there's enough zero-point energy there that if you could extract it, you could boil all the oceans on the earth. So there's limitless energy in the 0 point. Now, this guy, Morey B. King, he got interested in the stuff of Morey because he had an unusual first name and Morey has an unusual last name, so he thought, oh, that means I should study his stuff. He thinks Morey was getting the energy from the 0 point. Maybe I'm wrong. Maybe he is getting it from the 0 point. I think he was getting it from the Fitzgerald-Tesla-Schumann resonances, but I could be wrong. Well, let me tell you my definition of a true scientist. A true scientist is one who holds every proposition with a light grasp, ready to surrender it upon encountering new evidence or better arguments. So everything I'm telling you, it could be wrong. I'm just, you know, you got to think for yourself. Oh, that's what Einstein used to say. I was at a party of 32 Rhodes Scholars. I was alone with Einstein for 15 minutes, and then the director of the Rhodes Scholarships thought I was unfair to the other 31 Rhodes Scholars, so he had a sailing party, and he invited Einstein as the guest of honor. And so we were all there for a few hours with Einstein, and then it was time for us to leave, and so the director of the Institute for Advanced Study, a man named Frank Adelot, who was secretary of the American Rhodes Scholars, he said, now, Einstein, do you have any parting advice for these young men? And Einstein thought, and he said, well, if I could give the young men any advice, it would be this. Don't believe anything is necessarily true just because you read it in the newspapers or hear it on the radio. Always think for yourself. Now, I asked Einstein to autograph a book for me, and he never did it, but as a special favor, he did autograph that book. And it was sitting on my shelf when I was at Hughes Aircraft Company, and I had 12 PhDs working for me, and one of them piped up at a staff meeting, and the secretary was there, and he said, you shouldn't leave that book with Einstein's autograph in the shelf. It's valuable. And guess what? The next morning, it was gone. So either one of the 12 PhDs or the secretary stole it. But I know how to get it back, because if I go to New York and say I want an authenticated Einstein autograph, and there's probably only one in the world, they got to show me the provenance, and I'll trace it back to one of those men or the secretary. But anyway, I did bring you something to show about Einstein, and that is, get your library to get this wonderful book here. It's called Einstein, The Life of a Genius by Walter Isaacson. Now, he has another book that's just thick, standard type book, but this is not a standard type book. This book here has fold out, you can pull out things which are actually perfect duplicates of the original documents. It's just fascinating stuff. You can see the letter that Leo Szilard wrote a letter to President Roosevelt, alerting him to the possibility of an atomic bomb. And he, a man I consider my friend, Eugene Wigner, I knew him at Princeton, he was a Nobel laureate. Wigner drove the car with Szilard, and they went to Einstein's summer home near New York, and they showed Einstein the letter, and he signed it, and then they knew some financier who took it to President Roosevelt, and that started the atomic bomb. And so they have the original letter here from Szilard that Einstein signed. They have all that stuff. A fascinating book. Get your library to get it. Okay. Now, here's another book, The Tesla Papers, Nikola Tesla on Free Energy and Wireless Transmission of Power. Now, I think Tesla was deceiving himself. Tesla discovered the Schumann resonances, but he thought he could put energy in and take energy out. And Tesla's plan was he was going to get the energy from Niagara Falls, and he was building a big tower, and he was going to put it into the Schumann resonances, and the people in England could take it out. So he thought he could transmit wireless transmission of power. But I think Tesla was deceiving himself, because I think the same amount of energy is there all the time. And if the people get it out in England, it's not because he put it in here at Niagara Falls. It's because the energy, as you saw from that graph, it's just all over the world. Okay, so that's another one of the books. And I think I've showed all the books now, so maybe we'll move on with my talk. Oh yeah, there's one other book. This is very important. Beyond Oil and Gas, The Methanol Economy by George Olah and his associates, Jeppert and Prakash. And Olah is a chemist who won the Nobel Prize, and what he says in this book is, if there was a cheap way of getting solar energy, you could take water and air and create methanol. You could replace all the gasoline that everybody drives in their automobiles by methanol, and when you drive down the road, the methanol gets converted into water and carbon dioxide. And so what you started with goes back, and the amount of carbon dioxide that goes into the air from your automobile is the same amount that was taken out to make the methanol, so it's carbon neutral. So now, when I told Jean Manning, the author of one of these books, that I was going to advocate the methanol economy, she said, oh no, because it'll take fresh water away from people who have all over the world there's a fresh drinking water problem. Well, I studied it last night, and he does say in here, that doesn't say it work in the internal combustion engine, but he says if you did it in a some kind of a catalyzer that made electricity while you're driving, what would come out would be perfectly water and carbon dioxide. And so there is a way of doing it, not with an internal combustion engine, but with some other kind of engine. I've forgotten the name of it, but you could replace your automobile. And then it also says, if you're not worried about using up the water for a while, very, very small changes in everybody's automobile would make it work on methanol instead of gasoline. So anyway, now, my first slide. Oh, yes, you told me to. Okay, yeah, you told me to put. Okay, yeah, yeah. Okay, that's the title of the talk, and that's my contact information, and I have business cards if anybody wants to contact me. I'm glad to send them copies of these technical papers. So now, Is there a way to freeze the amount of carbon dioxide in the Earth's atmosphere without rendering the present transportation infrastructure obsolete? Nobel laureate chemist George Olah has already written a book on the methanol economy, which I head up. If a completely green source of renewable energy becomes available, such as hyper-efficient solar energy, then atmospheric carbon dioxide plus water can be converted to methanol as a replacement for gasoline. But the carbon dioxide released by combustion of the methanol merely replaces that taken out to produce it. So the total amount of carbon dioxide remains unaltered, and concern regarding global warming disappears. So I have been trying for 2 years to contact Al Gore and saying, Nobel laureate, he got the Peace Prize, Nobel laureate Gore, here is your holy grail. It was discovered in 1926 and it was lost in 1939, but if it was rediscovered, you wouldn't worry. Okay. Now, this here says incontrovertible evidence of a magic bullet solution to free renewable clean energy problem was demonstrated before Nobel laureate physicists and chemists 1923 to 1940, but was lost because the United States Patent and Trademark Office mistakenly said, a cold cathode is physically impossible, and denied a patent to T.H. Moray's germanium triode. I'll show you a picture later of his patent application. He applied in 1927, and it was rejected 1929. But that's only part of his problems. But in the book written by Moray and then re-edited and reissued by his son that I showed you, he says quite plainly that Moray disclosed every single thing that he knew to 2 or 3 people, and one of the people that he disclosed was Harvey Fletcher. And so the fact that 2 of Harvey Fletcher's subordinates invented the transistor seems to me circumstantial evidence that finally Fletcher got so frustrated that he broke Moray's confidence. I don't want to defame anybody unjustly. I'll just say that a lot of Moray's friends think that, and Moray himself says, no, I don't suspect Fletcher. He's an honorable man. But it sure seems to me pretty suspicious that Moray showed Fletcher a rejected patent on a germanium triode, and then that was in 1927, and then in 1939, Fletcher started a project on solid-state physics at the Bell Telephone Laboratories, and in 1940, it says 1947, that's wrong, 1948, they announced the transistor, but the definition of the transistor was a piece of germanium and 2 gold strips. And I just think it's too much of a coincidence. But I don't want to slander Fletcher, so it could be just a coincidence. But I think it's suspicious. Now, this says a startling new development. I have to qualify this. It says, miniaturized partial rediscovery of the lost secret of the Moray device was confirmed by 4,000 hobbyists. Well, it's true that 4,000 hobbyists a couple of years ago bought a manual that told them how to do it. And the person that was selling the manual, he said to me, I sent a letter to all of them, and if anybody said it doesn't work, write me back. And he said, not a one of them wrote me back. But yet I never could get the name of a single person who bought the manual and tried it and said, yeah, it worked. So a friend of mine who I wrote an appendix for his book, which was a bestseller, and at the time he was quite affluent, he gave me $1,000, and he said, you pay $1,000 to some expert in electrical engineering and electronics to duplicate what it says in this manual. And so at the time I was in communication with a professor at, I don't know whether it's Denver University or University of Denver, but they advertised that they're the Catholic University for Independent Thinkers. The person who ran their electronics laboratory actually was a Methodist or something. But anyway, I paid this guy $1,000, and he followed the thing, and he says, yeah, it works, but it doesn't give 2.5 watts. It gave me something like a milliwatt. So so when we say that that this Hungarian has duplicated, that's questionable, because when I asked the publisher who sold 4,000 copies of the manual, he says it was a fixed price. I gave the Hungarian the money, he gave me the thing, and then he disappeared. So we can't track down the Hungarian who claims that he did it. But I have something which is much more scientific to approach all this stuff, and that's why I'm glad I met Professor Lee. I have a patent issued and now expired, and anybody who sends me an email, I can send you a copy of the patent. Equation 10.29 in that patent, I just say how to derive it, but I don't give the actual coefficients. I showed them to my friends at the time, and we had them. It implicitly explains in the patent how to derive these. I say they're hellaciously complicated algebra. That is true. And what I call them, it says somewhere here, but it's got one letter left off. I call it the EMTFD equations, electromagnetothermofluid dynamics, EMTFD, the EMTFD equations. And I worked them out since 1960, let's see, since 1960 to the present time. I've worked them out and written them on a piece of paper. They fill 6 lines, ordinary size type, doesn't go the whole way across, about 1/3 of a page. And I've shown them to people, and I've lost them 3 times. And my friends said, don't admit you ever lost them. They'll think you're stupid. Well, I lost them. Anyway, the first time I did it, you're expanding a 6x6 determinant. And it took me 200 hours a year for 5 years. I was doing on great big sheets of paper. And the second time I did it, I had a MATLAB symbolic algebra engine of a crude type, and I would type in a formula, and it would say that string is too long, so I would have to call it A and B, and type in A, and then type in B, and then type in A plus B. And it took me hundreds of hours of typing, but it didn't take thousands of hours. And so I printed out the 6 formulas, and then I put them on a page, and I sent them to 2 people. Only 2 people have tried to do it, but they got wrong answers. And in my patent, I pointed out the algebraic mistakes they made. There's a famous professor at MIT named Bruno Coppi, C-O-P-P-I. And so I joke, I sent a copy to Coppi. And I mailed him a copy of the 6 formulae to sort of nudge him, you know, you made an algebraic mistake, but here's the right answer. And I also mailed a copy to an application for a job in the plasma physics laboratory at MIT, but I didn't get the job. And when I went back to them and said, I lost a page, please give it to me, and they said, we lost a page too. Anyway, I'm trying to do it for the 3rd time, and I'm making great progress, because technically I'm a candidate for a master's degree in electrical engineering at Florida Institute of Technology, where I taught systems engineering for 10 years at night when I was in Maryland from 1998 to 2007. And I audited courses on electrical engineering given by my friend George Masters, Dr. George Masters, who had recommended they hire me. I audited his courses. I had to pay taxes on getting the courses free, but I did audit his courses, and I got credit for all those courses. So all I have to do is submit a master's thesis that he approves, and I will get a master's degree. And so because technically I'm a candidate, I was able to get a cheap copy of MATLAB. Instead of 2,000 or 3,000 for 200 or 300, I got it. And so in my spare time at home, I have been trying to do this work again for the electromagnetothermofluid dynamics equation, EMTFD, to get the 6-degree polynomial. And the important thing about the 6-degree polynomial is it factors into 3 quadratic equations. Now, here's the importance of the 3 quadratic equations. 2 of them are generalizations of something already known. But when Alfvén, A-L-F-V-E-N, he derived them, he took 1/c, where c is the velocity of light. He took 1/c equal to 0. He assumed that light was infinite, and it's not. In my version, 1/c is positive. So I have a generalization of the 2 quadratic polynomials that Alfvén derived. He called their solutions the slow magnetosonic waves, and get the roots of the other one. That's the fast magnetosonic waves. Okay, I have got a more accurate version of the slow and the fast magnetosonic waves of Alfvén, And if he deserved a Nobel Prize for those two polynomials, then I ought to deserve a Nobel Prize perhaps for the third quadratic polynomial, which doesn't give you the magnetosonic waves, it gives you the electromagnetosonic waves. And that's what I really think we need to know in order to design an antenna to tap into the Moray, I think the Fitzgerald, Tesla, Schumann resonances, if you did it conventionally, a quarter wavelength antenna, it would be 200 kilometers long. But Moray used an antenna that was 90 yards long. But there's some strange things about what Moray did, which I really don't understand. And those are explored at length in this book here by Moray King, The Energy Machine of T. Henry Moray. And he says, well, I tried to interest a Nobel Prize winner in physics in this stuff once. And he says, look, if somebody was getting 3,500 watts through a little thin wire, it would be red hot and it would be corona discharge and everything. But everybody said the wire was cold. And another weird thing, it has photographs here in this book. Moray would say, cut the wire, and the wire's coming down, and they cut it, and he would put a sheet of plate glass here, and the current would go through the plate glass and still lit up. He had a bank, a 35, 7 rows and 5 columns where he had light bulbs, and he would get 3,000 or 4,000 watts with the light bulbs, but he also lit up a waffle iron and a motor. So he was getting between 3,500 and 5,000 watts. His son, who's now 83 years old, told me that eventually he got it up to 50,000 watts. So somewhere Moray was getting the energy. I think he was getting it from the Fitzgerald, Tesla, Schumann resonances, but I could be mistaken, of course. Now, I've already said this. In 1926, Tesla observer T. Henry Moray stunned credentialed witnesses by producing 25 kilowatts of AC power 26 miles from the nearest power line using a short antenna plus a germanium triode decades before transistors. Now here's a picture of Tesla, and this is Tesla with one of his lightning producers, but people say this is really a double exposure, that Tesla photographed himself there, and then he went out and photographed it again with the lightning coming, and so apparently it's a double exposure. But anyway, I'm showing you this next thing. It may or may not be worthwhile. How much time do I have left?
You have about 30 more minutes.
30 minutes?
Yes.
Okay. I'll tell you why I'm showing this, even though it may be worthless. I'm showing you this to prove that I did, in fact, attend to several of the Tesla conferences in the 1980s. I would spend my spare time thinking about the Moray thing, and then I went to a Tesla conference and I heard all these people speak, and I have some of the proceedings of some of the Tesla conferences here. But in order to justify going, I did give a paper myself. Now my paper may or may not be worthwhile, and I'll explain to you why it may or may not be worthwhile, but if you look at section 11, Self-Sustained Longitudinal Waves by me, Dr. Robert Bass. Okay, now here's why it's a challenge. Every book on electromagnetism says there is no self-sustained oscillation that's a solution of Maxwell's equations in which the E field and the B field are going in the same direction. They said it's impossible. Well, I proved it's not impossible. I got a rigorous mathematical solution, but there's a catch. And the catch is, look at the geometry of my longitudinal self-sustained waves. There's just a portion of it, but see, it's really like a torus. Now, I don't think you can generate that. If you want to generate it, you would have to put a peculiar thing at each end where you had a peculiar dipoles at each end, and I don't know how to make those dipoles. So the only thing I could think of the use of this, well, if this thing was really like a torus and is a self-sustained electromagnetic oscillation, maybe it's a model of an elementary particle. There's people who speculate that protons and neutrons and all that are just little vortices in the ether. Well, I've got a rigorous mathematical solution of Maxwell's equation that is a self-sustained longitudinal oscillation, and it could be of any size. Maybe it could be small enough to be an elementary particle. I don't know. But anyway, I just given this to show that I did go to the Tesla meetings. But when cold fusion came out, I dropped my interest in the Morey stuff, and I dropped my interest in the Tesla stuff, and I changed to cold fusion for the next 23 years. If you go to Barnes & Noble, you buy a magazine that comes out every 2 months called Infinite Energy. You'll see I'm on the board of editors for the last 23 years. And I was invited by the American Chemical Society in 2010 to give a 1-hour presentation at their annual meeting on what I claim is the only conventionally viable theory of cold fusion. So if anybody wants a copy, I'll send it to them. But anyway, now we come to the Schumann resonances. And if you look in this book here, he shows how to make an approximate solution of the relevant equations. Now, these are the equations that you people are studying under Professor Lee right now. Okay, here's the kind of approximation he makes. Well, if I've got c, the velocity of light, divided by r, and r is between the surface of the Earth and the ionosphere, well, it's about 4,000 miles this way, about 40 miles that way, so it doesn't change very much. So instead of putting in r, I'm going to put in a constant, and that's an approximation. Now, this is what mathematicians call, you know, a heuristic, H-E-U-R-I-S-T-I-C, a heuristic approximation. Change the problem so you can solve it. And so finally, he comes out with a solution, and he comes out with a solution where the answer is something like this. It's like the velocity of light divided by the radius of the Earth multiplied by the square root of n times n plus 1, where n is an integer, 1, 2, 3, 4. And so if you look at the lowest 4 or 5 things, they come out to be 7 hertz, 7 hertz, and 9 hertz, or whatever. But anyway, they vary like the square root of n times n plus 1, where n is 1, 2, 3, 4, 5. And you'll find that all explained in this book. Okay, so now it says up here, I copied it out of that book. The resonant frequencies are called Schumann resonances. They're extremely low with A, that's the diameter of the Earth or the radius of the Earth. The first 5 resonant frequencies are 10.6, 18.3, 25.8, 33.3, and 409. Actually, they came out later. I think they go to 8 or something. But anyway, here is experimental measurement, and here it says the Schumann resonances are at 8 hertz, 14 hertz, 20 hertz, and 26 hertz, and additional peaks at 32, 37, and 43 hertz. So that's the first 7 of them, and they have been measured. And NASA has found that the Earth, see, when you solve them like this, you assume the surface of the Earth is a perfect metal conductor. You assume there's a vacuum. You assume the ionosphere is another perfect metal conductor. And so it's an idealized model. Well, it really should be a model of a cavity with leaky boundaries, lossy boundaries. And NASA has found that the ionosphere is particularly lossy, and a lot of it gets through, more than people thought gets through, and they measure it out at 100 miles altitude or wherever. They have a satellite up there that is trying to predict global problems like power outages and things like that, and it has been measuring these things, and now they say, oh my goodness, they have the same frequencies as the Schumann resonances. So NASA has written a bunch of papers on it lately. Now here's another way to do it. These are the people who measured the Schumann resonances at different places all over the world simultaneously. Antarctica and British Columbia and Great Whale River, PG, wherever that is. I don't know where that is. Okay. Now, here they plotted it a different way, and from the slope they said these have to be the Schumann resonances because they're so similar. And those are the E fields and the B fields. In the Schumann theory, the B fields are just great circles going around the Earth, tangent to the Earth. But the E field points out radially everywhere. But the problem is the E field is reversing direction whereas the other one is always going in the same direction. And so to figure out an antenna to catch that and not take 200 kilometers like the quarter wavelength, but to do like Morey did and do it in 90 yards, that's a big project, and I hope somebody here will solve it. Maybe I'll live long enough to see somebody do it. I'm glad Professor Lee is an expert in designing antennas. Maybe he'll do it or have one of his students do it. Okay, now here's an actual eyewitness drawing of the antenna. This is, you know, it's not to scale because this is a 6-foot high tent pole, a 6-foot high tent pole, and the distance between them is about 90 yards. No, 30 yards, about 90 feet. Variously, they say 78 feet or 87 feet or whatever, but anyway, you can track that down in the book. And then there is a wire from the edge of the antenna that comes down to a box of electronics, and then a wire that goes from the electronics to a ground, and they pounded the ground 10 feet in. And the witnesses were allowed to pick an arbitrary spot in the desert, 25 or 50 miles from the nearest power line, and it always worked. Now here is a copy of the patent application for a germanium triode, which the patent office said in 1927, a cold cathode is physically impossible, and rejected his patent. So the poor guy, he was cheated of a Nobel Prize that was given to 3 subordinates of Harvey Fletcher for germanium and 2 gold strips. Okay, the most credible witness of the Morey vow was the late Harvey Fletcher, 1884 to 1981, called the father of stereophonic sound and a longtime director of research at Bell Labs. While a student of Millikan, Fletcher had measured the charge on an electron in an oil drop experiment. That's the famous oil drop experiment. And Millikan got a Nobel Prize, and all of Fletcher's friends said, well, you conceived the experiment, you did it with your own hands, you were cheated out of a Nobel Prize. So I am 82 years old, and I personally knew 2 of the 3 most important witnesses. Of course, all 3 witnesses are passed on now. But I knew the 3 most important witnesses, according to the book. 3 most important witnesses are Carl Eyring, Henry Eyring, and Harvey Fletcher. Now, when I was a professor of physics and astronomy at BYU, I worked in the Carl Eyring building, but he died not long before I got there. But he was a famous person, so I never met that famous witness. But I did meet Henry Eyring, and in fact, I got the job at BYU because Henry Eyring recommended me. And Henry Eyring was called, because of his rate reaction thing, he was called the most quoted chemist in the entire world. And the reason I say Henry Eyring is a Nobel caliber is because 5 minutes after he died, the telephone rang, and people calling from Switzerland, the Swedish Royal Academy, said, well, we've just given the Nobel Prize in Chemistry to Henry Eyring. And his relatives said, too bad he died 5 minutes ago. Anyway, that happened this past year, but instead of just giving it to the runner-up the way they did with Eyring, they actually gave it to the person who died 5 minutes ago. So unfortunately, Henry Eyring did not get the Nobel Prize, but he knows for a fact that if they used the precedent of today, he would have gotten the Nobel Prize. So Harvey Fletcher deserved the Nobel Prize given to Millikan, and Henry Eyring deserved the Nobel Prize that came 5 minutes after he died. And then the third witness was Carl Eyring, and I worked in the Carl Eyring building. I never met him. But anyway, Henry Eyring was an emotional man, and he recommended me, and I got a full professorship there, and I was there for 10 years. But one day I said something to him that really annoyed him. There was a whole audience sitting, and I was drawing on a board, and I was talking about controlled thermonuclear fusion. That's my topolotron patent. And I said, okay, here's the whole world. We're coming down the road, and we come to a fork in the road, and everybody in the world goes that way, and I go tiptoeing down that way. And Henry Eyring raised his hand. You say anything like that again, and I won't support you anymore. But it's true. My colleagues who signed my patent on the topolotron had PhDs from Harvard and Princeton and are Nobel Prize winners, and they agreed with my mathematically rigorous proof that my topolotron would produce between 37 and 43 times more energy per unit volume than any possible tokamak. And today, the government of the United States, the government of Japan, and the government of the European Union are spending $10 billion to build a tokamak in France. Well, if the tokamak in France is worth 10 billion, my topolotron, whose patent has expired, should have been worth 370 billion. Anyway, I did talk to Harvey Fletcher when he was about 97 years old, and the year before he talked to me, allegedly to, quote, clear his conscience, he had signed an affidavit that it was true that he had seen this thing, and when people asked him about it, he changed the subject or he prevaricated because he was embarrassed to admit that he didn't know where Morey was getting the energy. But when he was on his deathbed, he signed an affidavit. Yes, it couldn't possibly have been a fraud. Morey was really producing between 3,500 and 50,000 watts of energy from nowhere. I don't know how he did it. Okay. Now, I just showed you my paper on the longitudinal waves. In the 1980s, I gave papers at several conferences in honor of Tesla, in which I showed there's enough energy in the Schumann resonance in the Earth ionosphere cavity, which is replenished by lightning strikes. Now, I said here that 1 kilowatt, that's not true. I think it's like 1 microwatt or something. I've been going over that with Professor Lee, and we're trying to decide who to believe. There are people that say there's 500 megajoules in a lightning bolt, and so on and so on. But anyway, this 1 kilowatt should be 1 milliwatt or 1 microwatt.
I think it's 1 milliwatt, maybe more recent.
Yeah.
And that's huge energy too. If you multiply it by the surface of the Earth, that's mind-boggling number.
Oh yeah, and it's more, it's 3 times more energy than all humanity consumes from every known power source. So if we could figure out, if anybody here could figure out how to tap into the Schumann resonances, or excuse me, the Fitzgerald-Tesla Schumann resonances, then you would solve the Earth's energy problem. Of course, the clouds are lifted by solar energy, and so the energy in lightning strikes comes ultimately from the sun. The problem is how to get a very high frequency AC current from a standing wave which is oscillating at about 8 hertz, and in which the B field circles the entire Earth like an equator, while the E field is always radial but continually reversing its direction. Conventional antenna theory for extremely low frequency, ELF, waves requires an antenna, I say here thousands of miles long. It could be as little as 200 kilometers if it's quarter wave. Now here's my big conclusion. It seems to me there is some trick for getting around that proposition into which Morey had stumbled during invention of his radiant energy device without actually understanding what he'd done. He wrote about the sea of energy in which the Earth floats, and here's why I don't believe that it's 0-point energy, and here's why I respectfully disagree with a person whom I greatly admire and respect, Morey King. Here's why I disagree with Morey King. 2 things. Morey said the energy is not a simple oscillation. He says it comes in surges like ocean waves. 0-point energy is uniform. It's uniform everywhere in the whole universe, and so it won't come in surges. Now, the second reason why I think it may be the Schumann resonances and not the 0-point energy is that Morey said it's more energy in the daytime than at the nighttime. And NASA has found a big difference in the Schumann resonances in the daytime and the nighttime. But 0-point energy, it makes no difference what the weather is or what the daytime or nighttime. So it could be that instead of designing an antenna, you got to design something more like a microphone using my electromagnetosonic waves and take acoustic waves into account. So I think Morey had done this without actually understanding what he'd done. He wrote about the sea of energy in which the Earth floats and said that the radiant energy comes in surges like oceanic tides, so one may need to go beyond the standard theory of the Schumann resonances by means of the theory of electromagnetosonic waves based upon an electromagnetothermo, I left out the T, electromagnetothermofluid dynamic, EMTFD, theory disclosed by me in the second one of my BYU topolotron patents. And then I give an online reference. So I hope that someone here may make progress in this field. And I thank Professor Lee for this opportunity, and may someone here got interested, or Professor Lee get interested, and just keep in touch with me, and I can send you copies of all the, I'll give you titles of all the books, and I can send you copies of all the papers.
Okay, do you have any questions or comments? Well, I have one comment. So, in conclusion, you said you have no doubt whatsoever there is enough energy in our atmosphere. I mean, it's not really 0-point energy. You think the energy is coming from Schumann resonance.
Yeah, yeah.
Then how much confidence do you have, Dr. Murray collected the power? I mean, can you, here's some situation that someone says yes and someone says no. I mean, how could you be more affirmative when he collected like a 50 kilowatts?
Well, I haven't told you all the drama in some of these books. In the early 1930s, when Roosevelt started the Rural Electrification Administration, the REA, it was later investigated by Congress, and it's not speculation, it's a proven fact. The REA was infiltrated by communist sympathizers. And the communist sympathizers brought a professor of physics all the way from Russia to look at what Morey was doing. And he says it's real, it's not a fake. And so the REA was trying to learn the secret and send it to Russia. And so they told Morey, we'll give you a 2-year contract. I talked to his son on the phone the other day, and he says, yeah, but Morey resigned before the 2 years was up. But anyway, they told Morey they would give him a PhD assistant for 24 months, and they would pay him $25 a day consulting fee for 2 years. In those days, that was big money. And so Morey started working with the assistant. Well, it turns out the assistant really was just trying to learn the secret so that he could tell the Russian professor or persuade Morey to emigrate to Russia. And so finally, toward I have said it the last day of the 24-month contract, but Morey's son told me on the phone yesterday it wasn't the last day of the contract, it was just partway through the contract. But the Felix Fraser, who was the man from the REA trying to learn the secret to give it to the Russians, he went temporarily insane. He picked up a sledgehammer and he pounded the Morey radiant device to smithereens. And I asked Morey's son yesterday, was he ever able to rebuild it? And he said, no. He said, we never had the finances to rediscover it because he used rare things, like he had this thing he called a Swedish stone, which is a piece of germanium that he picked up when he was on a mission for the LDS church in Sweden. And he said it would take a lot of financing and a lot of studying of crystals and everything to rediscover the exact thing. And it wasn't only the Morey valve. When he demonstrated to witnesses, Morey would let the witnesses take everything apart, put it back together again except one little part. He kept that in his vest pocket. And when the witnesses would say, okay, we've studied everything, everything's fine, no batteries, no tricks, no nothing, then he would say, okay, I'm going to put the Morey valve in. He concealed it in his clenched fist, and he would stick it into the box and back off and say, connect everything, and then he would get 3,500 watts. And all the witnesses said it was 3,500 watts, and later it was raised to 10,000 watts, and finally 50,000 watts. But when Felix Fraser smashed Morey's thing, Morey was never able to get power again. And so the whole story is a tragedy. But I think it's a historical fact that Morey got huge amounts of energy from nowhere with an antenna and a box of primitive crystal radio set era electronics. So here's a challenge to everybody. Rediscover the lost secret of the Morey radiant energy system.
Can you comment about this patent issue, about rediscovery?
About the patent issue.
Well, suppose someone actually find out the secrets.
Okay, all right, yes. I passed the patent bar exam myself because BYU spent about $500,000 getting my first Polytron patent. And my second patent on the plasma sphere I just did myself. I passed the patent bar exam. I studied every summer and finally passed it. And I can tell you this about patent law. There's a doctrine called lost art rediscovered. And here's an example of a lost art rediscovered. If you get a statue of an ancient Roman wearing a toga, you look at it carefully, there's a safety pin. But somebody in modern times rediscovered the safety pin, got a patent on it because the art had been lost. Nobody in the 1,000 years in between the Romans had used safety pins. So there is a legal doctrine that everybody accepts called the patentability of a lost art rediscovered. So if we rediscover what Moray did, we could get a patent on it. Now, as far as my own work goes, I handed out my business card. If anybody knows an inventor that wants to work, I would love some work. I'll do high quality work for half the price that anybody else charges. So, but anyway, the only thing, if an investor came to me and said, I want you to try to rediscover the Moray thing, I couldn't promise him I'd rediscover the Moray thing, but I could promise him just one thing. I could get a patent on, quote, a method and procedure for more accurate modeling of the resonances in the Earth ionosphere cavity. Because I would use my EM-TFD equations, those 6-degree equation that factors into 3 polynomials, 2 of which Alfing got the Nobel Prize for. The third quadratic equation, you get its complex roots, and it tells you a sinusoidal wave that's exponentially decaying. And I am sure I can get a patent on that because I can prove that 2 world-famous experts tried it, and in my patent I pointed out mistakes they made. There's a man who won the Nobel Prize in astrophysics called Chandrasekhar. And Chandrasekhar told his best student, S.K. Trehan, I want you to work this thing out. Take this 6x6 determinant and expand it, and go all these equations. And somewhere, Trehan made a mistake. And I have 6 copies of a book at home because I thought I might have 6 collaborators one day. I got 6 copies of an out-of-print book, rare out-of-print book, that has a chapter by S.K. Trehan where he tried to derive it and made an algebraic mistake. And then this professor at MIT, Bruno Coppi, he made an algebraic mistake. Guess what his mistake was? There are 5 physical factors and 1 geometrical factor. The 5 physical factors are thermal conductivity, electrical conductivity, hydrodynamic viscosity, the reciprocal of the speed of light taken not to be 0. That's 4 physical constants. And the 5th thing is a geometrical constant called the Helmholtz number. The Helmholtz number, a mathematician like me would say, it's just the eigenvalue of the Laplacian operator in the cavity that you're looking at. And I have to say to people before they ask questions, I'm a trained mathematician, but I'm just an amateur engineer, an amateur physicist. But anyway, if you have the Helmholtz number and you have those 4 physical constants, then you can write down these equations. Now here's the mistake that Coppi made. He said, I'm going to take these one at a time and put them equal to 0, and it makes the equation simpler, and then I work it out and get the answer, and then I got 4 different answers, and then I'm just going to interpolate between the 4 answers. But that's wrong. Here's why it's wrong. I have already proven, that the constant term in the 6-degree polynomial is a product of those 4 factors and the geometrical factor. So if any one of them is 0, you change the order of the polynomial from 6 to 5th, and so there's a linear factor, and that linear factor is just what they call an entropy wave. And so you can't possibly get the right answer. So when Coppi thought he would simplify the problem and interpolate between 4 or 5 simpler problems, he was making a tragic mistake. And I tried to tease him by sending him a copy of the real answer, and he claims, I don't remember getting it, and I don't have it if I did get it. But anyway, I'm hot on the trail of deriving those equations again. And I used to tell people, if you give me enough money that I could work for 1 year, I'd do it. Now I'm telling people I don't need that much money. I'm getting closer. So,
do you have, by any chance, any record whatsoever Dr. Moray did? I mean, is there any written document how Moray designed his device?
This thing here is full of documents and signed affidavits. The only thing wrong in this book, I'm about to, he's got some pages of electromagnetic theory with a lot of misprints. I spent several hours writing it all down. I'm about to send his son. But his son was kind enough. He has the conclusion by R.W. Bass. He has a new foreword by R.W. Bass, but he says somewhere, we don't necessarily agree with the opinions of R.W. Bass. His father thinks that he needs $5 million to go through Moray's original 1940 plan of going to Germany and Sweden and everything and collecting all these crystals and doing this and that and the other. In other words, Moray was having a big, big plan to make his Moray valve more reliable, because Moray admitted that something in his system burned out after 200 hours. And it wouldn't be commercially valuable unless it would run for 1,000 hours or so, and it always burned out after 200 hours. So Moray was always trying to get enough money to study how to make it more reliable, and that's what the Sun is trying to do. I think the Sun is on the wrong track. I think the Sun shouldn't be trying to figure out how to do a transistor. I think we can, if we know the specifications, today's physics is so advanced, we can design a transistor that does anything you tell it to do. The real problem is what Professor Lee is trying to do is circuit design and the electromagnetic way to tap into some electromagnetic waves in a cavity that we know are there.
Any comments, questions? Well, there is one thing that I want to put. Yes, go ahead.
I was just going to ask, so you mentioned that if we did have an antenna that would be able to do this, it would have to be really long on the scale of like 200 or more kilometers or so. So if we did have something, a structure like that built, would we be able to recreate what Moray did?
I suppose so. See, I'm not really an expert on antennas. You asked Professor Lee, but I have heard the phrase quarter wavelength. The standard antenna is a quarter of a wavelength. And so if a quarter of the wavelength is 200 kilometers, you've got to start with a 200 kilometer long antenna.
I think you have a very valid question, but the problem is when you make an antenna long, you have losses involved. So making the antenna small and the capture over large area, because it's effective area, that can be challenging. So I would say the answer is possible, but we don't know how. Maybe that's what Dr. Moray did. He actually did the antenna small enough to collect enough power rather than making, it's not more, actually it's more than 200 kilometers. It's going to be several hundred kilometers to make it effective antenna. And you're going to have a huge losses. See, we have an energy that is less than a few milliwatts within, say, per meter area. Okay, so consider the wire that has a conduction and losses involved. And by the time you collect the power from all these structures, it may be negligible. So the key here is maybe any of you can have some idea how to make this antenna small and collect enough power without too much losses. I think that's the key here. So my thinking is it is possible, but we don't know yet. Actually, I don't know yet.
Mm-hmm.
And the key here is if you find what it is, you can make a lot of money because it is protected according to his knowledge in patent law. Mm-hmm. But at the same time, you are serving humanity, and you may get a Nobel Prize, maybe more than few times.
Yeah, so it's interesting, but it's something to be grasped that isn't in our hands.
Okay, do you have any questions, comments?
Oh, by the way, I invited a reporter from the Star Telegram. Is the reporter from the Star Telegram here?
Well,
okay. Apparently he didn't come.
We can do that once this is recorded.
All right, you're going to put it.
Yeah, I'm going to do that.
Yeah. Okay.
And well, just one last comment here. He has more or less a physics background, and we are more like an engineers. Mm-hmm. And when we study this electromagnetics, we always talk about E and H. Mm-hmm. But he's doing E and B. So that's the difference between physics and electrical engineering. Yeah. Okay, so I want you aware of that. You know the convention of E to the J omega t? He's using E to the plus I omega t. That's one difference between physics and electrical engineering. And another difference is we are using E and H, not E and B. Mm-hmm. H and B are related. Mm-hmm. And we call it permeability. But the way you present the data, you usually use B, E, engineers use H. Yes. So I want you aware the differences here.
Right, right.
Okay, any questions or comments? Well, if you don't have any questions, let's give him a lot of applause. And yeah, today I give you an early release so that you can enjoy the nice weather in the outside. Thanks for coming by, and I'll see you on Monday.
Let's pack up everything in my bag.